Welcome to Pre-Algebra with Miss Betsy. Today we are going to be discussing how we find the least common multiple between two or more numbers. The text that I'm using today is Pre-Algebra for Christian Schools. It's the first edition, published by Bob Jones University Press. We will be on page 163, section 5.7, entitled Least Common Multiples. The second edition orders things differently. The section numbers are not the same. They're still going to be covering the basic material for how you solve least common multiple problems. So you can still gain valuable information from this video regardless of what edition you're using, or if you're even using a BJU Press book at all. It really doesn't matter. You're going to use the same methodologies to find least common multiple. So let's go ahead and pray, see what our lame joke is, and we'll dive right into our material. Father God, we love you today, and we thank you for the scent and feel of fall that's in the air. And as we're entering into cooler weather here, Father, I'm reminded of the promise of spring coming again after the winter and how you make all things new. Lord, I ask that you would help us to keep our eyes fixed on you today, that we would learn to recognize your voice and to follow your direction. I ask that you would give my students the ability to comprehend new material and that you would help me to articulate it clearly to them. We love you and we pray in the name of your Son, Jesus. Amen. Okay, can you tell me how the snake kept his windshield clean? Well, he used his windshield wipers to keep his windshield clean. So, least common multiple. Now, if you have this text that I referenced, the first edition of Pre-Algebra for Christian Schools, I think their chart is a little bit incorrect. They're wanting to have written multiples of 3 and multiples of 4, and they're saying we're going to multiply first by 1, and then we're going to multiply by 2, we're going to multiply by 3. So we can think of this all as counting simply by 3s or counting by 4s. 3 times 1 is 3, 3 times 2 is 6, 3 times 2 is 6, and I write a 2. Or 3 times 2 is 6, times 3 is 9, times 4 is 12, 15, 18, 21, 21, 24, 27, 30, 33, and 36. These would be the first 12 multiples of 3. 3 times 2, 3 times 5, 3 times 8, 9, 10, 3 times 10 is 30, 3 times 12 is 36. So let's do the same thing for our 4s here and write the multiples of 4. And of course we have 4 times 1, and now I'm just going to play dropsy. 4 times 1 is 4, times 2 is 8, times 3 is 12, 16, 20, 24, 28, 32, 36. We have the first 9 multiples of 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And they're just our times tables. 4 times 8 is 32. 4 times 9 is 36. So this is what we mean when we're talking about multiples of a given number. Now, let's look at what we have here, and let's circle the numbers that show up in our list of multiples of 3 and our list of multiples of 4. Well, we have a 12. See what else? 6, 12, 24. Anything else? And we have 36. Now, because these are all 12, 24, and 36 are multiples of 3, 12, 24, and 36 in our second row are multiples of 4. These are going to be what we call common multiples of 4 and 6, of 4 and 3. Common multiples. And this doesn't mean anything mysterious. This is just a very straightforward English definition. These are multiples, and when you have, and they're common because they're found in both places. So you can look at this pattern, you see we have 12, 24, 36. The next multiple that they're going to have in common is 48, then you're at 12 again, and it's going to be 60. So there's a pattern of common multiples between the two original numbers, 3 and 4. But what we're looking for is the least common multiple. Now, we don't tend to use least a whole lot in our everyday English speech anymore. But if you're familiar with the story from the Old Testament of when the prophet Samuel is coming to the house of David, and he is looking for the man that he knows God has called to be king over Israel, and Jesse brings all of his sons before the prophet Samuel, and Samuel keeps saying, God, it's got to be this one. Look, he's so big, he's so strong, he's a warrior. No, it's not this one, it's not this one, it's not this one. And then there are no more sons of Jesse that he brings before the prophet. And the prophet says, are these all of your children? Are these all of your boys? And David says, well, and Jesse says, no, well, there's one more, but he is the least of all of his brothers. And David, and this was, of course, David, who God was calling to be king over Israel. Anyway, I'm getting sidetracked in my Bible story, but David refers to himself as the least of his brothers. And the least means the smallest or the youngest. So the least common multiple here means the smallest multiple that the two numbers share in common. So a least common multiple, or the LCM, of 3 and 4 is going to be 12. There are many common multiples. We've listed 3 of them here, 12, 24, 36. I told you 48, 60, 72, I think 90, maybe not 90, 72, 90. There are many common multiples, but the least common multiple, or the smallest number, the smallest multiple that they have in common, this is what they call the least common multiple, or the LCM. And this is what we are going to be looking for. And this is the ability to determine the least common multiple is very important when we're working in algebra, and we'll see its application as we go on through this course. So, there are a couple of different ways that you can find least common multiple. The first one we just illustrated for you right here, where you just look at the different multiples of a number and you pick the very first multiple that appears, or the smallest one, and that is exactly what they want you to do in example 1. Example 1 tells us to find the least, it says, list multiples to find the LCM. So this is example 1 in your text, and it says list multiples to find the LCM. And they want multiples of 10, and they want multiples of 12. We want to find the least common multiple of these two numbers. So if we have tens, it's 10, 20, 30, 40, 50, not 15, but 50, 60, 70, 80, 90, and so forth. And what are we doing here as I'm listing these multiples of 10? Well, I'm simply counting by 10, aren't I? 10, 20, 30, 40, 50, 60, 2,220. You know, multiples of 10, you're just adding 10 at a time. Now, what are the multiples of 12? 2 times 12 is 24, 3 times 12 is 36, 4 times 12 is 48. We have any common multiples yet? No, because they all ended in a non-zero digit. But our next one right here, we now have a multiple of 10. So 60 is both a multiple of 10 and a multiple of 12. And not only is it a multiple of these two numbers, but it's the very smallest one. Because the next multiple that you're going to have in common with these two numbers is 120. And obviously 60 is smaller than 120. So what we would say is that the least common multiple is equal to 60. Okay, what's our next one going to be? It's going to be 180, then it's going to be 240. So the multiples are spread out more than they were when we were looking at 3 and 4 as the number we were looking for a common multiple, but you still see that there's a regular pattern: 60, 120, 180, 240, 300, 360, 420. There's a regular progression, but the very first time that you have a pair, that you have multiples in common, that's what the LCM is. It's the least common multiple, or the smallest number. Your text tells you that the LCM is the smallest number that is a multiple. It is a multiple of the given numbers that you've been asked to find the LCM of. Okay, example 2 is going to have us find the least common multiple of numbers by using a different methodology. And this is where we're going to use prime factorization. And you can already see, even just based on this example, that if you have two wildly differing numbers, if you had to sit down and write out multiples until you finally got of a bunch of numbers, until you finally found where you had that same common multiple, it could get to be a very, very, very lengthy process. So there has to be a methodology out there that helps you to be able to do this. And sure enough, there is, and it's called, and it uses prime numbers. I'm looking for my notes. And it uses prime factorization with exponents. So if you look at your text on page 164, it tells us what you need to do to find the least common multiple using exponents. So we're going to find the LCM using exponents. First, we're going to prime factor each number, and we're going to use exponents because if we have 12, when you prime factor that, it's 2 times 2 times 3. This would be the prime factorization of 12, but you can use exponents to say that 12 is equal to 2 squared times 3. So first we want to prime factor using exponents, and then we're going to write a product of all the prime factors and you're going to use the highest exponent of each, and I'll illustrate what I mean. Use the highest exponent of each. And then finally, what you have to do, you simply have to multiply those factors together to get a number. We are going to multiply those factors. So, let's see what example 2 is in our text, and we'll see what we do. It says, use prime factorization to find the least common multiple of 12 and 18. So what's the first thing that you have to do? You have to prime factor and use exponents. So we're going to say that 12 is equal to, and 18 is equal to. And I just prime factored 12 over here. You can use your factor tree, you can use upside down division, and you will quickly learn the prime factorization of some of these smaller numbers to where you don't have to continually use the factor tree. Here I have 2 used as a factor twice, times 3. And it says use exponents. So prime factorization of 12 is 2 squared times 3. Now they want to know the prime factorization of 18. So we're going to prime factor 18 using either upside down division or a factor tree. And I'm going to choose to say that 3 times 6 is 18, and then 2 times 3 is 18. So I have the prime factorization of 18. That's 2 used as a factor 1 time, times 3 used as a factor twice. How else could I have initially factored 18? I could have said that 18 was equal to 9 times 2, and then that 9 was equal to 3 times 3. But this is what the prime factorization of 12 and of 18 looks like when you use exponents. Now, our next step says write a product of all prime factors. So the least common multiple is going to be a product of all of the prime factors. What do they mean here? They mean each unique prime number. We only have 2 prime numbers that are being used here as factors. We have 2 and we have 3. And we write it as a product of all of the separate prime factors, all the separate prime numbers that are used as factors. Use the highest exponent of each. We have an exponent here of 1. You don't see it, but if there's not an exponent, you understand it to be 1. So we have 2 squared. The squared is the highest. And here we have 3 to the first and 3 to the second. So we have that the least common multiple is 2 squared times 3 squared. Then our final step says let's multiply these factors out. So we have 2 squared is 4, times 3 squared is 9, and you have that the least common multiple is equal to 36. So this is an easy one to verify just by writing out multiples. Let me do this for you now. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. First 3 multiples of 12. Now we have 18 times 1 is 18. 18 times 2 is 36. Our common multiples show up very quickly. Least common multiple is 36, which is exactly what we found by prime factoring these numbers. So let's go ahead and do another problem. And so far, I've just prime factored 2 numbers You can use the same methodology to prime factor 3 numbers or 4 or however many to find, of course you're going to prime factor them, but you can use this methodology to find the least common multiple of any number of numbers. Example 3 says we want to find the least common multiple of 4, 18, and 45. So we have 4, 18, and 45. 4 is easy, isn't it? It's 2 times 2, but we want to use it to illustrate it using exponents. So we have 2 squared. 18, we just prime factored. Reverse the tape if you don't remember that. And that was 2 times 3 times 3, which is 2 times 3 squared. 2 times 3 is 6, times 3 is 18. So 2 times 3 squared. Now we have 45, and that's going to be 3 squared times 5. How do I know that? Well, I know that 45, I could say it's 3 times 15, but I pull my multiplication fact that says 5 times 9 is 45. 5 is a prime number. 9 is not prime, but that becomes 3 times 3. Both of those are prime numbers, so we now have that 45 is 3 squared times 5. So what we've done now is we've completed the second step. Well, we've completed the first step. We prime factored and we're using exponents. Now we are told write a product of all of the prime numbers. So you're going to say that your least common multiple is, how many prime number factors are there? We have a 2 and a 3 and a 5. 2, and it has to be a product, times 3 times 5. What is the largest exponent for each one of these factors? 2 squared, 2 to the first, it's not a 2. 2 squared is the highest exponent for the 2. 3 squared, and we have 5 to the first. So our least common multiple is 4 times 9 times 5. Which I think is 180. 4 times 9 is 36 times 5. 5 times 6 is our 30. And you carry 3. Our least common multiple of 4, 18, and 45 is 180. So we're following this methodology. First we prime factor each number. We write that prime factorization using exponents. Then we show that our least common multiple is a product of the distinct prime number factors with the greatest exponent that is used. Use the largest number of times. Then you multiply those prime factors out to come up with your single number that is what your least common multiple is. Now sometimes when you're working with larger least common multiples, when you're learning the methodology, your text will say leave the answer in exponential form. So make sure that you're reading your instructions carefully. Now let me go ahead and do some of our skill check for some final illustrations here. The skill check is page 165. And it says, use multiples to find the LCM of each pair. It says problem 1 and 2. I'm not going to do that. You guys already know how to do that. And then 3, 4, and 5 says, list the multiples to find the LCM of each pair. This is example 4. When they say list the multiples to find the LCM of each pair. The least common multiple here is going to be 30, but they want you to list the multiples of 6. 6, 12, 18, 24, 30, 36. You don't even need to show that 36 because you know that your multiples of 10 are going to be 10, 20, 30. And there you have the solution to this problem where you would say that the least common multiple is 30. You have done what they've asked you to. You have listed the multiples of those two numbers. Then you have to actually tell me that the LCM is 30. And now they say use the prime factorizations to find the least common multiple. They're just going through and making sure that you understand the methodology. This is skill check number 7. We have the 20 is equal to 2 squared times 5. 50 is equal to 2 times 5 squared. So they've actually already done your prime factorization, and they want to make sure that you are remembering step 2 that says you write a product of all of the unique prime factors, prime numbers that there are, use the highest exponent of each. So we are going to have 2 squared times 5 squared, which is 4 times 25, which gives you a least common multiple of 100. So they're saying make sure that you can use this pattern properly. We're even going to give you the prime factorization. And then as you finish up with your skill check problems, they're saying, okay, we're not going to give you anything. We're going to expect you to go through and prime factor. So we have 8 and 18. Find the LCM of each pair using prime factorization. We have 8 and we have 18. 8 prime factors into 2 cubed because you have 2 times 4 is 8, and then 2 times 2 is 4. You now have 3 prime numbers. And how would you express 2 times 2 times 2 as an exponent? Well, it is 2 used as a factor 3 times. So we have 8 is equal to 2 cubed. And then we have 18, which is 2 times 3 squared. We've prime factored this one a couple of times today. So 18 is 2 times 3 squared. So you have prime factored 8, you prime factored 18. Now you know that your least common multiple is each unique prime number factor, the greatest number of times, with the highest exponent that's out there. So you have 8 times 9. So the least common multiple of 8 and 18 is 72. Now let me take just a second and validate this for you one last time, just by writing multiples. What are multiples of 8? 8 times 1, 8, 16. 8 times 3 is 24. I'm thinking up to the 32. 24, 32, 5 times 8 is 40, 48, and 7 eighths are 56, 8 eighths are 64, 8 nines are 72. Now let's see what our multiples of 18 are. You have 18 times 2 is 36, times 3 is 54, times 4 is not 72, but it's 77. And right there, you will see that the very first time we have multiples that show up both in the list of multiples for 18 and in the list of multiples for 8 is at 72, which is the least common multiple that we arrived at using the methodology of prime factorization. So go ahead and work on these. If you get stuck, send me a text, give me a call, or ask me a question in class on Friday, and I'll see you then.